In the previous class, we saw that AutoRP uses flooding and pruning method to discover RP. And the multicast address that is used to discover RP is 224.0.1.39 and 1.40. But this AutoRP, it's a Cisco proprietary, so not everyone will be having this option AutoRP. And secondly, that's a drawback of flooding and pruning. Moreover, it is also using a protocol, AutoRP, additional protocol. So the best option is running BSR. BSR stands for Bootstrap Router. You see, if you're using PIM version 2, actually the default version is PIM version 2, so you don't need to worry about it. When we use PIM version 2, BSR is possible. If all router in the network is running PIM version 2, you can configure BSR instead of AutoRP. Both are similar only. See, in AutoRP there was one announce and discover. Here also similar pattern is followed. But the difference is you simply use your PIM, which is enabled on every interface. You don't need an additional protocol like AutoRP. BSR requires configuration that you configure BSR candidate. So BSR candidate is equal to announce command in AutoRP. RP announce, you remember we saw. So when you configure a BSR candidate by using this command, say instead of saying IPPIM send RP announce, you remember in the previous class we did it. Send RP. Instead of saying send RP announce, we say BSR candidate interface loopback 0, something like that. So this is the command to you to advertise a router as as RP, and the mapping agent. Similar to AutoRP, the mapping agent, in order to configure BSR, we need to follow the steps. See, what are the steps? This is the command to introduce as a candidate. IPPIM BSR candidate. When interface contains the candidate BSR IP address, it is recommended but not required. The hash mask length means the subnet mask length across all the candidate BSR. The candidate BSR is the largest prefix. No, this is not needed. Okay, forget about this prefix. These things only interface loopback 0, something like that is enough. Now IPPIM BSR candidate collects the candidate RP information and disseminates RP set information associated to the group. Okay, no, I'm not interested in all these things. Let's go to the important stuff. IPPIM RP candidate. This is for a particular group if you want to advertise. See, this is BSR candidate. This is RP candidate. These are the two commands you need to provide. This is equivalent to the mapping agent. You remember in the previous class when we do AutoRP, we did two commands. One is announce command, the other one is discover command. This is equivalent to discover. This is equivalent to discover. That is equal to announce, as it is said here. All right, so very simple. The big difference is you don't need to use another protocol like AutoRP, you use the same PIM which is already running on every port, every interface. And this is the hops, number of hops that you want to advertise. This may be the access list. Let's check in the command line what these things are. So that's a big advantage. Other things are similar, but the problem is in AutoRP. The problem is we use additional multicast addresses, reserved multicast addresses, which is not necessary here. So in any way, PIM version 2 BSR is the best. Any vendor you can run this. Let's do this. We will go and replace Anycast RP. Sorry, Auto RP. We'll go and replace Auto RP with BSR. Before that, I'm planning to remove that PIM sparse dense. We enabled both in the previous class. I'm going to make only sparse now. When you say only sparse, you no need to flood. There is no need of flooding now in BSR. So there is no need for dense. So we are going to remove all interface level configuration of PIM and replace it with IPPIM sparse mode, not sparse dense mode. I'm going to replace dense, sparse dense with only sparse. And then we will configure these things and we'll see how it works. Now I want to check show IPPIM RP. There is no RP, but when I try pinging some multicast, it will automatically discover the RPs. No, what a surprise. Which means it is working in dense mode. When RP is not discovered, it will work in dense mode. Let me try again. There is no RP actually, which means it's working in dense mode. See, I don't see any RP. Which means, it's working in dense mode. Let me go to R3 and check whether the auto RP that we configured still exists. Show IP. mroute will also show me. I see only 40, which means this is not announcing. I should see 39 also. That is the reason. So let us first enable auto RP, then we'll go to BSR. IP PIM send RP announce loopback 0, maybe hop count 3, scope 3, IP PIM send RP discovery loopback 0, 3. Now let's go and check from R1. I'll try to generate some traffic, and this time I'm expecting some, no, not it. Note it. Let's give some time. PIM 33333 ping. Okay, so why it's not showing? Show IPM route. Okay, the RP is learned just now, so we need to try now. Try again. You see, RP is now discovered. You will also see on router 7. Yeah, I'm going to remove this and we are going to put BSR. Before that, I want to show you, see, show IP PIM interfaces. You see, the version of PIM that we run is version 2. So it's well suitable for BSR. First thing, I want to delete those auto RP configuration that we did just now on router 3. Done. Secondly, I'm going to remove from all interface the PIM dense sparse mode, and then put only sparse mode. See, show run section IP PIM. This is what we have configured. We are going to remove this and put only the sparse mode. Enable config T interface range loopback 0. Right, and then we will say IP PIM sparse mode. I think I need to include one more interface for router 3. I have iPhone 1 also. Router 4. All right, so next is let us check show IP PIM interfaces. You see now it's version 2 and the mode is only S sparse mode. Go to R1 and try pinging, the ping won't happen. The ping won't happen because we don't have RP. What? I'm getting a reply. I'm getting a reply from router 2, which means, how come? Show IP BGP, sorry, show IP PIM, show IP M route. Okay, it has got some inputs. Let me go to router 2. How come did I remove the dense mode? Show IP PIM interfaces. Oh, look at this. This is in sparse dense mode for some reason. One of the interface, I have to remove these things. Default interface F1/1. Default interface. We don't have those interface, but those interfaces are still somehow reacting. And then show IPM route. Okay, this don't have any source and it's sparse, but now let us check. Go to router 1 and try pinging. Good, no one is responding. You need an RP, and the R3 is going to be RP. This time we are going to use BSR. I'm on router 3. IP PIM BSR candidate loopback 0, and the length of the mask is not necessary, just hit enter. Boom. Likewise, IP PIM BSR, no, IP PIM RP announce RP candidate loopback 0. Not necessary. None of this is not necessary. That's all. See, very simple. Just 2 lines command. See how easy it is. You no need to flat and learn RP. Now everyone will know it. You remember I told you, wherever the PIM version 2 runs, this advertisement will go. You can go and check. This is more faster. Show IP RP. Okay. It's not shown. Let me join a group and then show you. Show run interface loopback 0. Did I join a group? Okay. There is no group join. When you join a group, you will see RP there. Interface loopback 0. IP IGMP join group 239.10101. Now you see show IP PIM RP. Look at this. Look at this. How fast it is. Now let's go and ping from R1. When I ping, you'll get all those members responding. Look at this. I can see router 2, 4, and 7 in this group. You see how BSR is far better than Auto RP. All that is needed is PIM version 2. And PIM version 2 is the default one. Any question? Right. We are going to learn something called multicast source discovery protocol. Multicast source discovery protocol. This one is needed if you have more than one RP. So what I'll do is I'll have R6 as one RP and R3 as another RP, and I'll shut down this link, or I'll delete this link. You know why I'm deleting this? For R7, the nearest RP is router 6. Whereas for R4 and R2, nearest is R3. Now, for R2, nearest is both R3 and R6. It may register anywhere. The reason why I'm doing this is, okay, wait, I want to do something different. We'll make R4 and R6 as RP. R4 and R6 in two different corners. The reason why we have multiple RP is the routers will go to the nearest RP. But what if half of the group member goes to router 6? The other half goes to router 4. And the source goes only to router 4. Listen, source is registering only with router 4 or source registers only with R6. What will happen? There won't be sync. Let me explain you one more time what I'm trying to say. This is going to be one RP. This is going to be another RP. I'll call it as RP2, RP1. This is the nearest, so it will go and register here. Enroll here. This will also go and enroll here. Now this will go and enroll here. Now if there is a multicast source coming, it may go and register here. So only R7 will be responding because R6 knows only R7 as a group member. R6 knows only R7 as a group member. So what is the solution? We need to sync between these two. If you sync, all those group members learned here will also be seen here. And the source, if it is registered here, it will also be seen as a registered here. And that's in that way, you can have all the group members knowing about the source. Please ask me a question.
So basically, we just want the both RPs to be in sync so that members can fail over.
Yeah.
Yeah, that makes sense.
Now, how to do this? You need a protocol to sync between these two. The protocol is known as Multicast Source Discovery Protocol, MSDP. Multicast Source Discovery Protocol, MSDP. Now, how is this MSDP works? We need to have a common RP address. Let me show you how it works. MSDP peering command. Where is that peering command? Oh, here it is. All right, so we are going to send a peer message between two RPs. Here there are two RPs. One is 192.168.100.2 and 100.1. Between these two, there's a peer message going on. And security association request is also going on. Okay, you need to go to MSDP on RP1, give the address of RP2, and go to RP2 and give the address of RP1. That's it. You don't need to have one common IP address in any way. Let's try doing this. First of all, I'm going to remove BSR on router 3. I removed it. Next is I'm going to paste these two commands on router 4 as I said. Router 4 and on router 6. Both are in two different corners. Okay. Now I want to go to R7 and see who RP is. For R7, show IP PIM RP. Router 6 is the RP. Okay. Router 4 is not the RP. Whereas for router 2, oh, for router 2 is also 6? How come? Surprise. What is router 4 doing then? I can't figure even in R4. Okay, for router, come on, 4 also has got this. Show IP PIM RP. What a surprise. Every router is pointing towards that router. What happened? Do I have a loopback interface? Show IP interface brief. I do have a loopback interface. This channel interfaces comes automatically. Let me try pinging from R1, check whether all are responding. 247. Looks like all are responding. Okay, so it is now having show IP PIM RP. It's having router 6 as an RP. Let us shut down router 6 and see what happens. Router 6. Interface range F0/0-1 shut down. So what we'll do now is we'll check RP. Still it's 0666. No, it will go down soon. Or we'll try generating some traffic. Try again. Okay, I can see the result that I want to see. See, 2 and 4 is responding, which means 7 is not joining the group with R4. According to router 2, RP is router 4 now. No? Okay, I think there is something I need to clear. Clear IP mroute star. Also, I need to do it on R4. Clear IP. Okay, will not be RP. R4 will not be RP. What? Why? Receive registration from so and so. 4 will not be RP. Why? Let's try keeping them. Let me refresh first. Show IP PIM RP. 6 is down now. Come, this is still showing 6. Six is unreachable. Why it is still showing? Okay, there's another command, clear IP pim RP. Good. RP is refreshed. I would like to do this on all the routers to avoid confusion. Six is anyway down. I'll just clear it in 7. Okay, we have done this. Now I would like to check show IP mroute. So show IP pim RP. There is no RP so far discovered. Let me go to router 2 and check the same command. Show IP pim RP. Okay, according to router 2, R4 is the RP now. So switchover has happened. Now let us bring R6 also up. Right, let us go to router 7 and see the RP. Router 7, whom are you going to show as RP? Okay, this shows R6 as an RP, whereas router 2 shows... Oh, come on. I switched back. Anyhow, the failover happens that you saw, right? That is enough. Now what I'm coming to say is, in case if these two are not syncing, we need to have something. So that is what MSDP, so that will make this to sync. All right. Right now R6 in R6 is the RP. Okay. Now if R6 goes down, R4 needs the updated status, right? So you have to keep it in sync, so that if R6 goes down, R4 will be up to date to provide info. So go to router 6 and say IP pim MSTP IP MSTP peer. The address is, I'm in router 6, I'm saying 4444. Connect using the source loopback 0. That's it. This is the actual command. I don't know what was that we did in the document. Document is IPMSDB peer. Okay, this security association request. Okay, no problem. That is also IP PIM. Sorry, IP MSTP security association. Security association request. It is not in this particular version of operating system. Again, I tell you, it's not needed. It's not needed. The only command that you need is this one, which I have given here. The document is not matching this iOS. Now let me go to router 4 and do the same. IP PIM, sorry, IP MSTP peer. What is it? 6.6.6.6. Connect using, that is very important. You are using the loopback, no? So connect using source. That's it. That's all. You will see a neighbor now. Look at this. The session is up. Show MSTP, multicast source discovery protocol. Show IP MSTP peer. You can see that the peer is up. The peer status is up with 4444. Let me try pinging now on R1. Okay, let's go and check. Look at this. It shows R4 will not be RP because of what? Invalid RP registration. PIM1. Invalid RP registration. Why? Is anything wrong in R4? Let me check. Show IP PIM interfaces. Okay, these interfaces need to be removed. Interface range F1/0-1. No IP PIM sparse mode. This is what hindering for a long time. Okay, this is the reason why we did not see the failover immediately last time when I switched off R6. Anyway, now what I'm going to do is I'm going to see whether there's a sync happening between them. Show IP PIM, show IP MSDP peering. You see, Security Association has learned 4 peers. 6 message sent has come in because 6 is updating 4. Data packet came in is 3. So whatever 6 learned, R4 also learned now. Show IP mroute synced. So that as soon as R6 goes down, you will have R4. So this is the use of MSDP. Now let me try pinging from R1 one more time. I'm getting the responses. Let me shut down R6. And now I would like to, oh, come on, again I'm getting the same message. There is something wrong. How does someone get this? Why PIM registration, RP registration is not happening? Received registration from R1, yeah, because R1 is a source, but for some reason R4 is not accepting. Maybe it is because it is also an IGMP group member. Let me remove from interface back 0. No IP IGMP group. C router 6 MSDP is gone down. Now let me try pinging from R1. Right now 4 will not answer because I have removed 4 from the group member because I want 4 to be RP, but again it's not becoming RP for some reason. It says RP is router, nothing, no one. So no, that's not the place you need to see. Show IP PIM RP. Okay, looks good. It is 444 RP. I think now it is accepted. 4 is the RP. Let's go and check on R7. R7, it was my loopback. I should have not joined IGMP on loopback of R4 because that is an RP. Show IP RP. Yeah, see. Now they all agree for as an RP, and that RP is already synced with router 6, so up to date. Now, one more topic in multicasting is left called Anycast RP, which we'll do in the next class. Any question on MSDP and BSR?